All right, welcome everyone. I think we can start at least the introductions to the session. So I'm Kevin Roundy. I'm the poster and work in progress chair together with Brendan Saltaformaggio this year. And it's a pleasure to welcome you to this session. We have a lot of great talks. We're going to proceed by presenting thematically linked poster or work in progress talks in pairs. So we'll watch 2 talk videos, and then we'll be able to field several minutes of Q&A for each set of posters or work in progress talks. So please don't hold back with your questions. Remember that one of the main incentives for people to create a poster session is to get good feedback on their talks. So please do share your questions now in the session or offline with the authors. I'm sure they'll be eager to discuss their work with you. Thanks to Marcy Hilliker, who's advancing the slides for us today. So Marcy, can we show the agenda? All right, excellent. Okay, so our first pair of talks is going to be on the topic of finding vulnerabilities. So let's play those 2 videos and then we'll field questions.
Hi everyone, my name is Mohammadreza Ashouri, and in this brief video I'm going to introduce Rusty. Rusty is a fuzzing tool for the Rust ecosystem, and it works based on the combination of property-based testing and concurrent execution. So as you know, Rust is one of the most popular system programming languages, indicating that many programmers have had the opportunity to use Rust in different projects. There are many reasons for this success, mostly due to its performance and safety. However, despite all the advantages come with Rust, in this research I found there are also serious security issues in this ecosystem that can compromise Rust's core compiler safety features. To perform these security analyses, I created Rusty as a practical and fast fuzzing tool. In a nutshell, Rusty includes 2 main contributions. The first contribution is in Rusty's design, I use property-based testing to test those specific properties of given code hold for arbitrary inputs. Therefore, if an error is found, Rusty automatically finds the minimal test cases to reproduce the bug. In my method, input generation is determined based on value instead of type, making my tool much more adaptable. Furthermore, after identifying errors in target code, Rusty creates concrete inputs to build proof of concept or POC exploit to reproduce the bug. For implementing the exploit generation unit, Rusty leverages a concurrent execution engine based on the Z3 SMT solver. That was my brief presentation. For more details, please take a look at the poster. Hi everyone.
Hello everyone, my name is Abhinav Mohanty and I'm a PhD candidate at UNC Charlotte. I work with Dr. Meera Sridhar and my research focuses on securing web-based mobile apps. In this work, we do a security evaluation of SmartHome companion web-based mobile apps. An essential part of the IoT ecosystem is the companion mobile app that allows a user to control the IoT device while in their home and remotely. For example, fitness apps interact with fitness bands to monitor a user's heart rate. Hotels are piloting smart doors that replace keycards with companion mobile apps, and even automated garage doors and air conditioners are accompanied by mobile apps. In this work, our focus is to identify exploitable security issues in real-world web-based IoT companion apps, specifically smart home apps. We also aim to create proof of concept exploits for the security issues identified. Some of the web-based mobile apps in our dataset with a large user base include Belkin Vimo, Hydrawise Irrigation, and Smart Home Security. Our dataset consists of 102 web apps that have been separated out from a dataset of 2082 Smart Home companion apps. The state of the art is limited to analyzing security issues in native apps, and to the best of our knowledge, this is the first work that does a security analysis of web-based IoT smart home companion apps and demonstrates the consequences of each issue through either real-world case studies or hypothetical scenarios. In this work, we survey security issues in real-world web-based smart home companion apps with the goal of consolidating and mapping the web-based attack surface in companion apps with how these security issues affect a smart home ecosystem. We achieve this with a combination of proof-of-concept exploits and hypothetical scenarios pertinent to a smart home ecosystem. Our poster highlights some of the exploits we have created for this work. For future work, we will develop proof-of-concept exploits for the remaining security issues and also demonstrate the attacks on real-world IoT devices. Thank you, everyone.
Okay, excellent. We were happy to field questions now for these two posters. Unfortunately, it seems that Mohammadreza is having a hard time. Mohammadreza Ashouri is having a hard time joining the call. So I'm not sure if we'll be able to field questions for that poster for some, unfortunately, but any questions that you have, we can pass along to him, and very happy to take questions for our second poster as well. Please feel free to add your questions to the Pathable chat window, and also all of our speakers and presenters in the session, you're very welcome to unmute yourself and ask questions of your own. There's a question in the chat about the posters themselves and where we'll be able to find access to them. Those posters are going to be posted on the conference agenda. Our authors have been sending us those posters, so we will get those up as soon as we possibly can. All right, I've got a question about the. I mean, I love both of these posters because they're a lot of very high impact tools. Were there any surprises, Mr. Mohanty, in the types of vulnerabilities that you were finding in the web-based mobile apps, or any hint at like what are some of maybe the most common pitfalls that you see in these applications?
Can you hear me now?
Yes, we can.
Okay. So the objective of this work is not to like find new vulnerabilities, but to do a security evaluation of the smart home apps which have been developed using hybrid frameworks like Apache Cordova, Ionic, and other stuff, and look for existing vulnerabilities in them, just to check that are they using the security standards that have been set or no. And we found that most of the web-based apps, they do not actually follow the security standards, and they are very easily hackable. And like one of the very famous apps which has a lot of security issues, and we have emailed them also about it, is Belkin Vimo, and it has like over 1 million downloads, and it still uses a Cordova library that is probably 4 years old and has like known vulnerabilities. So there are similarly a lot of apps which have are affected by pre-existing issues, and we developed exploits for 4 of those issues, and we tested them on the devices as well.
All right, excellent. Thank you for that extra context.
Thank you.
All right, so Mohammadreza is at least in the chat, so he's able to answer questions in the chat session if you're able to. So feel free to direct questions directly to him there, and he may be able to join us later on as we progress. Any further questions? All right. Okay, second question. In the second work, the same work, what were the most common vulnerabilities, and can these easily be corrected?
The most common vulnerabilities were the developers did not use a content security policies, and that is easily correctable. And without that, most of the apps used inline JavaScript. So without a content security policy, the inline JavaScripts were already there, and the app was vulnerable to cross-site scripting. We found multiple apps vulnerable to cross-site scripting. And one more common thing we found was missing whitelists. Like these frameworks allow you to specify which domains can be accessed from your applications. And I think out of the 102 web apps, 80 apps almost did not use a whitelist. So we could easily, we combined the cross-site scripting with payload that could switch the web view to a malicious domain. Basically, without the whitelist, this is possible.
Okay, very cool. Very interesting. Thank you, and thank you, Ana Ferreira, for the question. She writes in the chat, very interesting work. Thank you.
Yeah.
All right. I think Mohammadreza may have just joined the session. So,
Hi guys.
Oh, there you are. Okay, excellent. Thank you for joining.
Sorry, I was looking for the link. I was a little bit confused to get here.
Okay, well, we're glad you made it. Yeah, could you tell us a little bit more about your plans for RustFuzz? I feel like it has an opportunity to be a very high impact tool.
Okay, thank you very much. Yeah, as you know, RustFuzz actually is a portable tool for performing bug fuzzing for the Rust applications, or more specifically for Rust binaries. This tool works based on concurrent execution. And actually, as I showed here, I could successfully find several vulnerabilities in the Rust core libraries. And the main issue here is basically Rust builders, in order to improve the performance of compiler, they used a bunch of unsafe libraries in the code to improve basically the performance. However, the downside of it is actually introduce a lot of memory violations and many bugs basically to host applications that import and invoke these libraries. So this is basically an ongoing work, and I'm glad that I could actually share the result here with you.
All right, superb, excellent projects here, and great presentations as well. Thank you very much. All right, so if there are any further questions for these two talks, please do feel free to pop them into the chat later. We can circle back to them as needed. But let's move on to the next pair of talks. Our next pair of talks are focused on the topic of secure development and security defenses.
Many organizations are adopting a DevSecOps approach for systems and software development, leveraging the speed of Agile and the power of automation to produce faster and cheaper results. But they are focusing only on tools without effective engineering for critical quality attributes. And because systems have not been engineered with sufficient cybersecurity built in, the current operating environment is frequently overrun by attackers. With good cybersecurity integrated into good systems and software engineering, we can improve quality and reduce this level of attacker success. In reality, these pipelines are two joined process flows that must be designed and managed and used together. The first is the software factory, and the second is the integrated infrastructure that controls the capabilities for each step in the product flow. Neither process is static. The technology must be continually updated to improve capabilities for the product as the product matures. Trust that the pipeline will deliver the needed cybersecurity assurance must be established. What are the threats that the to the product, and how will the pipeline infrastructure help in reducing this risk? What are the threats to the pipeline that could impact the product? This is a complex engineering problem. We propose the use of model-based engineering to support analysis of risk so that all stakeholders have a shared view of the cybersecurity role and capabilities of both the infrastructure and the product pipelines. Our platform-independent model can serve as a reference architecture for which specific solution architectures can be defined. Variations of platform-specific models can be evaluated in an analysis of alternatives, using the model to determine the best choice that delivers the needed assurance in a cost-effective structure. In addition, variations in threat concerns can be evaluated as the landscape changes over time to ensure sufficient protection remains in place. Current approaches that assemble the pipeline elements in an organic manner do not provide this opportunity for sufficient rigor. Well-engineered models that allow organizations to plan for and maintain the proper balance among functionality, speed, and cybersecurity will allow us to improve the operational environment. Thank you for your attention. Here's our contact information should you have questions or additional input.
Hello everyone, my name is Obaidat, and in this talk I will present our work in progress titled Mitigating Large-Scale Memory Exploits in IoT Devices Using Software Diversity. In this work, we address large-scale memory errors that are becoming popular in the IoT devices. The well-known techniques to resist and prevent memory errors such as DIP, ASLR, and more recently CFI have limited security guarantees, incur high overhead, or require special hardware extensions. The goal of this work is to develop a technique to reduce the impact and resist large-scale memory errors exploits in IoT devices. Our technique aims to provide multiple copies of the same IoT software with different binary implementations. This can be realized by generating semantically equivalent set of instructions for a target basic block in the IoT software with the purpose that each implementation requires a unique exploit to trigger the vulnerability, thus reducing large-scale IoT attacks. To achieve this goal, we utilize TOC, which is a program super optimizer and synthesis engine, to generate the semantically equivalent set of instructions. We also used Anger, which is a popular binary analysis and symbolic execution framework, to provide information to the TOC engine, since TOC may require some input from binary analysis expert. Furthermore, we used AFL Fuzzer to provide fuzzing input to TOC. Since TOC randomly generates test cases to validate the equivalence of the generated set of instructions. Since we had a promising preliminary results on a toy example binary program, we plan to use our tool on a connection manager software used in IoT devices that has known memory error and simulate the reduction impact for a large-scale attack scenario.
All right, excellent. Thank you very much for those two talks. We have both of the speakers here online. So please pass your questions into the chat. And while you give you a little bit of time to think about what questions you'd like to ask and queue those up in the chat, we do have a couple of questions for our previous set of authors. So we'll keep this slide up so you can keep queuing up your questions, but let me pass a question along to our previous speakers on the SmartHome Companion project. The question is, did you look at the ease of exploitability and the potential impact, or use a scoring metric like CVSS of the vulnerabilities that you found?
like it's not a concrete model we have created yet, but we are working on assigning scores to the vulnerabilities and seeing the ease of exploitability, because our next goal actually is to include some machine learning into that. So we are looking at a scoring system. I have a rough scoring system, but it's not concrete yet.
All right. Thank you very much for that.
I just had a quick question. I'm unable to see the chat and the questions. Is it I don't have access to that?
So what you need to do is go to ACSAC2020.cd.pathable.com. It's the website where the agenda and everything is. It's where you logged in to the session. And if you find posters too, you'll be able to click on the session, and then you'll be able to see the chat window and the questions that are pouring in.
Thank you.
Yeah, of course. There's another question from Mohammadreza. You already answered it a little bit in the chat, but if you'd repeat your answer here for everybody, Mohammadreza, the question was, considering Rust Fuzz, what kind of bugs can it find? Namely, could it be adapted to find some constant time violation with some data tainting or secret value, for instance?
So thank you very much for the question. It's a very smart question. Actually, as I stated before, most vulnerabilities are associated to using unsafe Rust code basically in libraries. And so as a result, mostly are related to memory violations such as buffer overruns, basically integer overflows, heap overflows, and these sort of vulnerabilities. So, I mean, if you can read basically the evaluation part of the poster, actually I mentioned all vulnerabilities actually I could find in basically my evaluation.
Okay, thank you very much for that answer and that question. Great question. We have a new question from William Cholter for Islam Obaidat on his IoT devices project using software diversity. The question is, have you had any issues with suboptimal diversified variants?
Yeah, hi. So we haven't tested our tool on any actual IoT firmware software. We're just playing with some toy examples, but we haven't had any issues so far with the tool. We just tried on a couple of examples, and it was working with no issues. So yeah. But if he have specific question, maybe he can reach out for my email and contact me.
Yeah, and as we've seen, we're happy if you have follow-up questions to keep taking them as we go through the hour. So thank you for that question. It does seem like just following up on that question, it does seem like that is one of the challenges in software diversity, is to find the right kinds of diversity so that you can attack different types of threats. Do you have, since this is an early stage work, you have kind of like a toolbox right now. Do you have any plans to extend this work going forward?
Yes. So just as I said, we only tried it on a couple of binary simple programs, but we want to adapt it to actual firmware and see what is the impact. Try to create multiple firmware with batch version, let's call it, and try to attack it to see what is the impact of our tool on this. The attack surface on a large scale, what would happen? The attack rate and the success. Would the IoT software crash? Would it the payload would be executed and so on?
Okay, excellent.
Mm-hmm.
Thank you.
You're welcome.
Was there a comment? Sorry. Okay. Okay, and William says he'll follow up with you for more details on that. Thank you for your great presentation, Carol. Obviously, it's always hungry for more details on this kind of thing. So I'd love to just get your thoughts. it seems like you have a lot of different players and trust relationships that you're trying to manage within this infrastructure. Could you comment a little bit more, maybe a little bit more length, that who would be using your framework, and how you expect it to fill in existing gaps?
Certainly. On the programs that we are actively working with right now, these are large major programs where in many cases the people that are handling the cybersecurity have never even met the engineers that are doing the design. So what we're looking at is using access to a single model as a way to start to share information, because we find that decisions are being made among multiple groups that impact each other, but nobody knows about them until you get down to the point where you're doing an integrated review, and that's 2/3 of the way through your program. And by that time, you've run out of money to start over, which is almost what you have to do when you have major design disconnects. And especially when they impact the final security of a product that you're dealing with. In many cases, the design weaknesses seem to be the toughest nut to crack in terms of problems. We've got tools to a certain extent that can come in and help us with the coding and the development of that. But if you look at the way a pipeline is designed and how the information flows through that, it's all based on the requirements that go in, how the engineers design the architecture as to what gets actually built. So we're trying to start with a good integrated understanding of how security is really going to work and how it's going to all be tied together from the beginning. Too many times the program office, the engineers, the designers, and the developers are all working around assumptions that if we get all the functionality that we're supposed to do, the security comes along as an automatic. And it obviously doesn't, because we've got too many pieces and parts that weren't built to work together. So forcing that and having everyone look at a shared view is what we see the model as actually being a good starting point.
Yeah, fantastic. Really facilitating those early conversations really eliminates so much pain.
Mm-hmm. Well, it's early when everyone, and I say everyone is really scrambling to just get their little piece done, because you're always under schedule constraint. But if there's no forcing function to look at how that interrelates with the other pieces in the design, we find that people just don't get to that point of doing the communications and the cross-functionality issues. This affects safety as well as security, but obviously we've been more focused on security. But we're seeing those as being really major issues as we get into more reuse of code, as we get into more sharing of third-party products, that we're really doing more tying existing pieces together. If there isn't a real good understanding in the design and agreement as to how security is going to play, we find them making arbitrary decisions at different points in time that don't fit together. For expediency's sake, as opposed to the final result. And there's just no way to backtrack on some of those things. Hope that helps.
Okay, fantastic. Thank you so much for that extra insight. Love all the discussion so far. Please keep the questions pouring in. We have one more for Carol online, and then we're going to have to move on to the next set of talks. David Ballinson asks, Carol, I'd like to look more closely at the poster and see how the framework integrates T and E. I'm also wondering how you ensure models are available.
Well, ensuring access to the models is going to be a challenge, and that would be program by program. But what we have found is that once you start putting the pieces together, then at least you've got the opportunity to have the sharing. Whereas if you don't assemble the information appropriately to begin with, everybody's working in their own channels. Really, test and evaluation is driven by your requirements. And we have found that T&E is frequently lacking because the requirements requirements were not appropriately structured to begin with. So we're using the model in an attempt as a forcing function to bring everybody to the table to really articulate what they need to do. Too frequently, we see people using standards, which are very, very general, or policies as security requirements, and those really aren't. You have to really look at what am I doing and how do I need to protect it, and what is my design going to do, or how is it going to react if an attacker does certain things? How should it fail gracefully instead of breaking and allowing all kinds of impacts that are unexpected? And so it's really forcing the engineers to think through the pieces. But most of these people weren't trained to do that. So we're really looking at bringing the security expertise earlier into the life cycle and earlier into the decision making. They've never been at this table before, and so we're trying to make a place for them.
All right, thank you very much for that insightful answer. And Dave Ballinson also sends his thanks in the chat as well. All right, let's move on to our next pair of talks. These talks are both by a overlapping set of authors on the topic of software compartmentalization. So let's go ahead and watch the presentations.
Hello, everyone. My name is Tuyong Zhao, and I'm a graduate student at University of Pennsylvania. Today, I would like to talk about the usability of a debugger designed for compartmentalized systems. So splitting software into isolated compartments is a well-known security technique. This tends to prevent vulnerability in a part of the program from affecting the entire software. But this design will make us pay in the debugging session as the program is divided into pieces and probably distributed in separate machines. So we could build this compartment-aware debugger, and we would like to discuss its usability in scientific research. Our debugger is based on GNU's GDB. Surrounded by this box is our front end, where we have this main process to manage all the GDB clients that is launched, corresponding to stubs running on top of the compartments. The user could then send instructions to the clients about what to do or switch between them, and this would solve our needs to debug multiple compartments with different processes. In the back end, the client was remotely connected to the GDB stub and is running on top of compartments via GDB standard remote protocols. Therefore, we could deal with the compartments running on separate machines and debug remotely. An example of the GDB protocol could be shown in this figure, as the action of the stub would only take place when specific instruction code arrives. An example output of two clients and some basic functions shown in this figure. The current prototype, however, still lacks some function such as tracepoint. It should be also noticed that the communication of the client and stub is not encrypted yet, so it's subject to attack as well. We'd like to keep developing and start using it internally in our group, and we believe this structure could be adapted to other research as well. Thank you for watching, and if you have any questions, please use the email link as well as the URL for more information.
Hello, my name is Stephen Kiriskio, and I'm a graduate student at the University of Pennsylvania. Today I'll be covering our case study of utilizing fine-grained compartmentalization with curl. To begin, I would like to introduce two key components of our project. The first component is compartmentalization, which is the partitioning of program into separate independent processes. This is useful in information security since it limits access to data based on the principle of least privilege. The second component is curl, which is a software utility that transfers data by using various protocols and is packaged by default into many Linux distributions. While compartmentalization is a useful tool for security, it is often not used as it is difficult to implement. To address this, engineers at the University of Pennsylvania have created libcompart, which is a library that facilitates the task of compartmentalization. To further understand and enhance the efficacy of this project, we implemented compartmentalization of curl's functions using libcompart. The first step in our process was to identify curl's critical functions by stepping through the binary execution with GDB. Next, we used libcompart to isolate the functions into compartments and create interfaces to handle the communications between them. After the compartments were set up, we adapted data structures from objects in shared memory to serialized versions that could travel across these compartments. For complex circular data structures, protocols were established to synchronize the global state across compartment calls. Finally, we tested our enhanced version of curl by transferring data from a local FTP and a remote HTTP server. Our results showed that the incremental latency of compartmentalization averaged no more than 30 milliseconds, and there was no substantial changes to the file's integrity. In conclusion, our study proved that libcompart can be used to compartmentalize large-scale open-source projects. With that, I thank you for your time and attention. If there are more questions, please visit our website or feel free to send me an email at the address listed below.
All right, excellent. So clearly both of these projects designed to tackle some of the really difficult things that come up when you try to compartmentalize a program and make it easier and more effective. So please feel free to start queuing up your questions in the Pathable app, where you can add your questions to the chat. And I guess please go ahead.
I have a question actually for the second poster. So I'm curious, you mentioned deriving serialization protocols for these more complex data structures. I'm curious if you could shed some light on how you came up with those protocols and maybe an algorithmic way of making that happen.
Yeah, sure. So one of the things we noticed was when we tried to serialize some, the way that the curl was set up was there's a global state data structure that's kind of passed around within curl. So and it was circular to some of the operation configs that were in curl. And there's multiple operation configs, one global configs, but they had references to each other. So the way that we kind of solved that was by first, because you only have one-way communication in order to preserve the communication relationship between two compartments. There's only you have kind of like a master and a subordinate data structures or a compartment structure. So you get one-way communication from the master, and so we had the master basically tell the compartment that it wants to operate in that, hey, I'm about to pass a function, so you need to synchronize. And here's the data that you need to synchronize with. And then on the compartment side, it would then use the data that the master had sent to basically replicate the master side. Then once the master side is replicated, it sends a signal back to the master and a return call to say, I'm good, I'm done, and it went successfully. Then the master will actually send the data it wants to run in the compartment, which then the subordinate would run that function and return the results back to the master. And then the master would request the state of the subordinate after it's run its function and then synchronize on the master side. Does that make sense?
Yeah, it makes a lot of sense. Thank you.
All right, great. Here's a question in the chat from Kevin Butler. I think either one of you could try and field this, or maybe both of you. The question is, very interesting work. When you say compartmentalization, does this relate to privilege separation as well? It would be really interesting to compare the manual efforts Neil Provost made with privilege separated SSH.
Junior, do you want me to answer that one, or do you want it?
Oh yeah, the libcompart actually does the privilege separation, and we have like this previous paper discussing when actually we're developing this debugger. We have this paper that creates some general cases. Some like use cases where like you have a simulated login system where you have this probably correctly typed or legal strings, and like that's that's basically done by the libcompart privilege separation, where only a certain part of the program could access to that part of the string.
I will say that the Provost paper is actually I would say some inspiration into the development of libcompart. So when we started on this project, the postdoc in the lab had said, "Hey, here's a couple papers I want you to read," and that Provost paper was one of the ones that we had to really understand.
All right, fantastic. Thanks everyone again for the outstanding discussion. Let's keep moving on to the next pair of papers. These are a little bit more loosely related, but they both are using machine learning to tackle really challenging problems in security.
Greetings, my name is William Cholter. I'm with the Johns Hopkins Applied Physics Laboratory. I will briefly present our team's work and progress on software attribution. Software attribution, particularly for malware, is important for law enforcement and nation-state cyber deterrence, but it is still more craft than science. Attributing malware is hard because often the binaries are all that remain after an attack. They may be obfuscated, which makes them harder to interpret. When not obfuscated, helpful information is missing, such as source code and version history. When a piece of malware has multiple authors, there is no obvious division of labor in the final product. Research in programmer style, or stylometry, shows promising results for attribution of source and binary code in controlled experiments, notably in work by Caliscan's research team. Those efforts have focused on machine learning. Some features are text, language keywords, disassembly, and code structure. However, stylometry has not been validated as an end-to-end solution for real-world software. Dauber's team has promising advances in multi-author attribution of source code. Our work seeks to get closer to the end-to-end solution. We build multi-author binaries from GitHub repositories. We focus on Windows C and C++ Intel binaries because they are still the most common in malware research. To add realism and increase our feature space, we build samples from multiple points in time in a repository's history for multiple CPU targets. We have validated Caliscan's work on Google CodeJam and our own malware dataset. Our framework also improves data label inconsistencies in the code author name and email addresses. We are now building our classifier. In the future, we hope to incorporate GitHub malware source code repositories identified by Rocon's research team. I invite you to read our paper and ask questions. Thank you.
Hello, my name is Brian Quinn. I'm a master's student in the Department of Computing Security at the Rochester Institute of Technology, and today I'm going to be presenting my work in progress on modeling and generating cyber attack data using generative adversarial networks. The most commonly cited issue holding back the research community from breakthroughs in applying machine learning techniques to network-based intrusion detection systems are the lack of quality labeled training data and the imbalance between benign and malicious traffic that exists in available open data sets. In this work, we propose the use of semi-supervised learning, a technique commonly used when the amount of labeled training data is insufficient. In particular, we use a generative technique which takes advantage of generative adversarial networks, or GANs. With a GAN, we are able to model the behaviors of an attack by training on an openly available intrusion detection dataset. With that model, we are able to generate novel malicious examples that reflect the characteristics of the original attack. These new examples can then be used to balance the original training data between malicious and benign examples, and to train an improved network-based intrusion detection model. An evaluation process described in Shevchenko et al. 2018 is used to determine how well the generator model represents the characteristics of an attack. The evaluation consists of two metrics, GAN test and GAN train. GAN test evaluates a classifier which was trained on real data samples against a set of generated samples. GAN train evaluates a classifier which was trained on generated samples against a set of real samples. Initial results of this work in progress show promising performances for two attack types, namely SSH brute force and botnet. Each model shows strong performance on the GAN train and GAN test metrics, though there are potential for improvements. Both models show an increase in accuracy on unseen real samples when a classifier using a dataset that contained novel generated samples over a classifier that was trained on only a subset of the original data.
All right, excellent. Two more ambitious projects here. So please queue up your questions in the chat on the conference app, and yeah, we're very excited very fun to see these ambitious projects.
So I'll jump in. I have another question, this time for the second poster. So when you are looking at these cyber attack net flows, I'm curious if you have a way of measuring how realistic the synthetic ones are to actual cyber attacks. Is there some metric that you're using there?
Right, so that's definitely one of the biggest parts. And forgive me, my internet connection might be a little bit unstable. So we did a couple steps to sort of try to ensure that the generated samples would be valid actual net flows that could exist. One of them was taking out features that could be like directly derived. There were some features of the net flows that were based on like averages, like average number of bytes or something. And so we sort of left those to be calculated after the sample was generated. And then something that we definitely want to pursue in further works is maybe creating a tool that can actually assemble the packets that would reproduce the features in a generated sample. So sort of like modify an actual net flow in order to produce those features. There was a paper that we found that they used a tool that sort of obfuscated a TCP connection, by changing some of those features within the connection, and it'd be really cool to like reuse that work for this purpose.
Yeah, really cool. Thank you.
Of course.
Yeah, that would be really impressive. I'd love to see that. So William, for your work, I can think of multiple applications for authorship attribution. One of them is, let's say you're thinking of finding an open source project to include, and you want to make sure that that I guess there's no malicious injected code into the project, or you might want to be able to identify adversarial people like trying to insert backdoors into code, or you might just be trying to identify malware families. Do you feel like and figure out which of them are related? Do you feel like, are those the kinds of use cases that you're going after, or what do you feel like you're most excited to address using this type of framework that you're building?
So you could definitely use these machine learning techniques for malware identification. And we've worked with some student research teams that are pursuing similar methods of classification. We're more concerned with attribution, just because we're looking more for support in forensics analysis, and also potentially finding people who are influential, whose contributions show up one place surprisingly that you might be able to use. But a lot of the same earlier work using machine learning is looking at a lot of the same kinds of features in a binary.
Okay, super interesting. To what extent do you think this can scale up? Do you think you could scale it up to all of GitHub, or would it be more of a targeted type of thing?
Yeah, so one of the big challenges is we're trying to build the software, and software on GitHub, especially with the Windows software we're looking at, doesn't necessarily want to be built. So the way we're trying to tackle this is by looking at the continuous integration artifacts that are used for spinning up the various tests. And there are also just a lot of toy projects that we're learning about. So it can scale, but there is a lot of chaff with all the good stuff.
Okay. All right. Fascinating. Two very cool, ambitious projects. Thank you very much. All right. Let's go on to our final pair of talks. These two are both very cool projects focused on vulnerability finding and even vulnerability generation.
Hello, my name is Yao Frampong, and today I'm presenting Hijacks, a human intent to JavaScript XSS generator. The motivation behind this work includes exploring a new area of offensive security research that combines natural language processing and automated exploit generation. We made Hijacks to help non-security practitioners secure their websites. Hijacks is an LLVM-based AAG tool that can convert text to code. Hijack takes an English description of an XSS attack, known as an intent, and generates the corresponding attack code in JavaScript known as a snippet. We use different data sets of intent and snippet pairs to train our sequence-to-sequence model for text-to-code generation. We create datasets using questions and answers from Stack Overflow. Some of our criteria for using data from Stack Overflow includes whether or not the question is JavaScript related, whether the answer includes JavaScript code, and the number of upvotes the question has. We also create datasets using transpiling. We use the Canola dataset, a dataset made by Carnegie Mellon designed to test natural language generation systems and transpile the snippets in the dataset from Python to JavaScript. We also create datasets from other online sources where we collect benign and malicious intent snippet pairs. Here's an example of our benign dataset. Here's an example of our malicious dataset. To evaluate the syntax and execution of non-malicious code, we use the Exprima and CompileRun Node.js libraries. To evaluate the syntax and execution of malicious code, we use different penetration testing websites. From our experiments, we learned that we could generate executable code with high accuracy given a dataset size of 2,000 to 20,000 entries. Future work for Hijack includes expanding the functionality to mobile apps and creating more complex malicious datasets. Thank you for your time.
Hello everyone, my name is Fadi and I'm going to present our poster, Guide Me to Exploit Assisted Trope Exploit Generation for HSQ Virtual Machine. The AG can be defined as the challenge of determining the exploitability of a given vulnerability. AG tools explore all possible execution paths that follow vulnerability state in the hope of one of the execution path reaches the exploit state. To do that, AG tools utilize a fuzzer which randomly generates input to be executed. With this execution, the AG tools explore only one execution path, and this can be repeated until one of the exploit state is reached. However, there is no guarantee to reach an exploit state with randomly generated inputs. Additionally, AG tools utilize a symbolic execution tool which explore all possible execution paths symbolically. However, they can encounter the famous path explosion problem since the number of the execution paths is enormous. Therefore, we present our tool GuideX, a prototype semi-automatic AG tool, which is the first exploit generation tool for the AVM implementations. Our tool differs from typical AG implementation as it does not rely on a fuzzer or symbolic execution tool. Let's look at how we see the AG problem. And when we analyze an exploit script, we see that the exploit script does not perform its final malicious activity immediately after the vulnerability is triggered, because it needs to be undetected by the security system. Therefore, the exploit script needs to set the scene for its final malicious activity. This preparation is done in several steps, and this allows us to deconstruct the exploit script into these smaller several exploit steps. We call this exploit step as exploit subgoals, and our tool expects these exploit subgoals are defined by the security expert who have thorough knowledge about their target application. So with the exploit deconstruction, we actually define checkpoints between vulnerable state and exploit state, and our tool can focus on synthesizing these exploit script for each exploit sub-goal in sequence, and then stitch up the exploit script to obtain the entire exploit script. To demonstrate that our tool can synthesize an exploit script for a vulnerability, we picked the CV 2015-511 as our case study vulnerability. And our tool can synthesize exploit script for this particular vulnerability in less than 15 minutes. Our tool explored more than 650 execution paths in this process. Thank you.
All right. Thank you for both of our authors. Another pair of ambitious and very cool projects here. So please queue up any questions you have in the chat for our two authors. I guess to the authors of the hijacks paper, I thought it was very clever and interesting that you decided to do this like natural language based generation. I guess natural language based specification of the types of exploits that that you think you could find? To what extent? So beyond the natural language, I mean, here you've got like usability clearly as a key goal. Could you comment just a little bit more on that and on what other kind of places there are in exploit generation that you think could help website developers to have a more usable system?
Well, for future work, we plan to expand this for web-based mobile apps as well, not just websites. But the main goal was to take an NLP approach. That way, you could also help people that are not that are non-security practitioners who may not know how to write XSS attacks. So our main goal here was to build a tool that can help them, and then for future work, hopefully expand that tool to be able to create more advanced XSS attacks and expand on other platforms as well.
Okay, very interesting. Very cool. We have a question came in through the chat for our second poster from Yuhong Lin. For the second poster, what kinds of CVEs can be studied using your system?
So actually, I don't understand what does it mean by what kind of CVEs, but I can say that like currently our implementation is for ActionScript vulnerabilities. However, with like the little tweaks, our tool can generate exploit for different languages, but the implementation should be changed based on the language.
Okay, thank you. Thank you. Got another question in for hijacks from Ryan Kaiser. For hijacks, have you considered NLP specification for other attacks types besides cross-site scripting?
For this paper, we want just to focus on XSS attacks for now, since they are one of the more prominent attacks, but the same process can be applied to any kind of attack in any kind of language. So we hope to expand in that field as well.
Okay, excellent. All right, if there's one more question, I think we would have time for it. Ryan, thanks you for that answer. All right, well, thanks everyone. Fantastic discussion. Really appreciate all the great questions and all the great answers and the great talks, the great research. So as we mentioned last time in our previous session, remember that for poster presenters, it's all about the feedback and the guidance that they could get or insights that you might be able to share. So on work that's in progress typically and building towards something that could be really impactful in the future. So please do reach out to our authors and you reach out to them for additional information. They've all created a 2-page poster or work in progress submission, and they also have these presentations and their posters themselves, which we'll be placing on the website as soon as possible. So thanks again to all of our presenters and to all of you for joining and for all the great questions. Oh, sorry, there is one final question, but feel free to drop off if you need to. But for Yuhong Lin, could you please be more specific with saying what kind? Oh no, sorry, that's from sorry. All right, I'm misunderstanding. That's a question from the author back. That's just a discussion there. So all right, well, thank you very much, and thank you very much, Marcy, for helping us out with the slides, and really appreciate it. And we'll see you tomorrow.
Thank you, guys. Great job.
Thank you, Marcy.